That's not the case. The queries are actually TypeScript, and we are actually running those queries, which is really wacky.
Right? It's like, wait, why did all our queries slow down for a second? It's like, oh, the GC was running.
You want a backend that the front end can say, hey, give me this data, and the backend says, sure, and then it hits 16 different services.
Today, I am joined by Thomas Ballinger, a Rust developer working at Convex, which is kind of a new database that has a bunch of interesting features surrounding like live updates and things of that nature. Thomas, do you want to take just a second to introduce yourself?
Sure, absolutely. And the first thing I have to do is say, like, yes, I write a lot of Rust. I haven't fully accepted that identity yet. I still, I learned to program with Python. I used to think of myself as a Python developer. About 8 years ago, I started doing a lot more front-endy stuff, kind of, or at least front-end web technologies. And now, I've been 2 years at Convex and doing, a fair bit of Rust, but I write maybe some of the least Rust at the company because I'm also doing some of the client stuff. But indeed, I love it's a good identity, right? I want to accept it. Yeah, I'm a Rust developer. That's right. Yeah.
That's a very humble and unique take for a Rust developer in my experience. Most people will write 10 lines of Rust and be like, I'm a goddamn Rustation now. Like this is my this is my new identity. Okay, cool. But you've certainly written a lot more Rust than I have. It's been on my backlog / to-do list for years at this point. And I will eventually get to it. At this point, I'm thinking what's going to happen is that I collaborate with, TJ or Primeagen or something, and we ship a Rust course on boot dev, and then I'll just take the Rust course.
Sweet. Perfect.
Obviously that I didn't
after you helped create it. Yeah. Awesome. That's really good. Yeah.
And then I'll finally get to it. So great. So from the research I've done about Convex, obviously it's a database written in Rust, which is already pretty cool. I'm familiar with, let's see, there's a few databases that I'm more familiar with that are using some of these kind of modern programming languages. For example, CockroachDB is written in Go.
Sure.
I believe last time I checked. I hope I'm not making stuff up.
I'm in it too. I just nodded. Yeah, you're good.
yeah. I think it is because it's almost like a distributed system type of database. That's one of the big, I think, selling points. And so they chose the language that Kubernetes was implemented in.
Mm-hmm.
Seems to make a lot of sense. Tell me a little bit more about the why behind Convex. Why does the world need this Rust-based database?
Totally. Yeah. So big picture, this is. So I was at Dropbox for a while, and a bunch of other folks there at Convex were too, and they were more on the infra side. I was doing some web tech-ish stuff. We were moving the desktop client from used to be kind of all Python and native stuff. Anyway, it doesn't matter what I was doing. I was doing my own stuff, but they were off doing this distributed system stuff, right? The infrastructure where they had. They developed some strong opinions about how one ought to build these kinds of systems. And some of those things were, it's query planners kind of suck, right? Or at least if what you're doing is trying to provide reliable service to a lot of people and it's a very large scale system, query planners can bite you. And so
can we pause for a second there and just explain what a query planner is for maybe some of the listeners that are new to that?
Absolutely. So there's this really neat language called SQL, which is kind of high level, right? You can you have to write out exactly which columns you want, but you don't give Postgres, say, a plan for how you want it to execute this query. You say, I'm going to join this little table with this big table. You just say, I want to join this table with that table, and you hope that Postgres says, oh, okay, I know some things about these tables. I know that I could just probably bring this whole thing into memory. And I know that I've got an index on the thing I'm joining on. So I'll use that index and then I'll grab each of those. So there's different choices you could make, right? When you write a SQL statement and ask the database to run it for you.
Yeah.
And that's great. That's really convenient. But sometimes you'd like to have a little more control. Sometimes a query planner makes a surprising decision. It could be the breakpoint between, once the table gets bigger than 1,000,000 rows, we think now's the time to start querying it in this different way, and you get different performance characteristics. And if you're trying to provide, right, if you're a platform level thing, if you're trying to provide predictable, say P99, because you're in a big system where those P99s kind of get multiplied, and every request coming from a user actually hits 16 different services, and so likely you are going to hit one of those P99s from one of your services. It's less reliable. And so they just repeatedly get bit by this the query planner, it's really smart, it's really convenient, but we would like to be able to hint it a little more. And they're using MySQL, which you can hint a little. Postgres is a little stronger about, look, we'll figure out how to run this query. You just tell us what you want to do. And it's a beautiful thing. It's similar to front-end reactive programming stuff where you say, hey, do this. and you figure out how to do it. Anything declarative or Elm or anything where you get to say, I'm going to describe what I want, like CSS, it's beautiful. This is what I want. You figure out how to implement.
I wouldn't go that far, but yeah.
But it's certainly you're totally divorced from the implementation, right? The browser takes care of how to implement this hierarchy of rules. And we've decided as web developers too, like, actually, I don't want that whole cascade. I want a little more power for myself. And similarly for, maybe it's a stretched analogy, but similarly, sometimes for building a system, you would like to have these reliable P99s. You would like to know that, hey, when I add another 100 rows to this table, things are going to get a teensy bit slower. And that's all. Yeah. There's no chance that by adding those rows, I completely change the way that the query executes now. And so that's one of the things that, these folks at Convex, an opinion they had about, like, hey, if we were going to build some of these systems again, here's how we might build them. And there's a few other learnings we could talk about, but it was things like that made some of the folks at Convex that I really respected. I hadn't worked very closely with because they were all the way over in infra, just developed over years and years of Dropbox opinions about how to build some of this stuff. And then when they were looking at starting a startup, we're like, I guess that's the thing we're kind of most experienced with. Do we really want to start an infra company? Gosh, that sounds hard, but that would be like we do have opinions about this, and we think we can provide a better way of developing to a lot of people.
Yeah, it's interesting that you bring up this idea of SQL being very high level, because I think it's easy, especially as web developers, to think that SQL is a very low level thing, because especially when we talk about like dropping down to raw SQL, because so many people use an ORM on top of the SQL, right? Which introduces another layer of abstraction. And this idea that, like, when you look at a SQL query, you have very little insight into how that is actually going to run on your machine, right? Because, like, if you just have the query itself, because you don't know what's indexed, what's not indexed, you might not even know the database engine that's being used, whether it's Postgres or MySQL, and they behave a little differently. Like you said, the size of the data can impact performance. Like, there's all this stuff going on underneath that, as you point out, like, you don't get to know just by looking at the query, which isn't true of like a lot of programming languages, right? Like, if you are looking at some C code, for example, like, you can, with a pretty high degree of certainty, know what's going to happen. There's, like, of course, some
right. The compiler can make some different decisions, but compared to SQL, right, they're very, totally.
So, anyways, that's a really interesting idea. So, would you say this is like the primary differentiator of Convex? The primary idea behind Convex is like, let's give you more of a look into how your queries are going to perform?
Totally. I'm trying to decide if I just pulled that one out of a hat, or I think that's an interesting reason that, or one of these philosophical differences, but and I think long term, yes, that may be for the vision for the company, but that is a big vision that's way out there. I think the big differences are trying to put, it's kind of like stored procedure, all in on stored procedures a little bit, like, just because. So a big difference is
scary.
Let's take the backend and stick it inside the database, right? There's sometimes we talk about, like, oh gosh, we need a what's it called, BFF or BBF. We have backend for the front end server, so that we can take so that the front end's not making multiple requests you don't want a round trip from your clients, whether they're front ends or whatever, from your clients to the backend and then to the database. Those are big round trips. It'll take a long time. If you could take your backend server and put it close to the database, now you can make one request to the backend, and you can have, a few round trips between the backend and the database. But if the database and the backend are really close together, if you smush them into the same thing, you have some different constraints. And it would be okay to say, gather this data and then gather this data, and then even say have a bunch of, you have different problems. And the claim is that those are simpler problems to deal with, because you are allowed to say, get this row. Okay, based on this row, get these other rows. Even, those levels of joins, you get to go all the way out. And that's how SQL works too. You say, I want to join these two things, but you give up that power, that extra precision. And so with Convex, I'll back up, I'll describe the whole thing a little bit. With Convex, you write code, you push your code to your Convex deployment, and those are sort of both your database queries and those are your backend API endpoints. Okay. So it's expanding more. And people have done wacky things with this, like, oh, we could get Postgres to like serve HTML. That would be cool. And it is pushing in that direction of, gosh, there's this impedance mismatch sort of between the backend or between your ORM and the database. If we could just smush those together, you would have some superpowers. And there are some other superpowers you get from this, the reactivity and the perfect cache invalidation. But I think the big idea is combine your backend server with the database. If the main thing that it is doing is like talking to the database, it's sure nice to not have any latency between those.
So I pulled up it's convex.dev, right?
Yeah.
The website.
Yeah.
And I'm going to read the kind of the hero section on the landing page. So it says the H1, the main header, says the only decision for your backend. And then the H2 is Convex is the open source backend for application builders and all-in-one platform with thoughtful product-centric APIs. So this to me looks like, is it fair to say that your primary competitors are like Firebase and Supabase when it comes to like feature parity?
Totally. Yeah. And you can, long term, who knows how those things go. But right now, it is absolutely like, hey, are you building a website or a React Native app? Like those are the clearest applications right now. And that's because one of the superpowers you get is, and the reason Firebase and Firebase in particular, because it's got that, Firebase really pushes the real time thing, right? Mm-hmm. With Convex, we're, due to some interesting, cool ways we run the queries, every query that only reads data, that doesn't write data, which we just call queries, and we make you call it's confusing because we make you call the ones that modify stuff mutations, which front end developers are happy with that. But in the back end, we're like, no, everything that talks to a database is a query. Anyway, if it only reads, if it's a query, you can subscribe to it. Any time that you write a query that just reads, and it's in Firebase, it's more about syncing tables. It's like, well, if you only selected a few things from a table, we can update that. But in Convex, we can kind of update anything. So you can say, oh, I want to, grab stuff from this table, grab it from that table, use this index to access this thing, join those together, munge it a little bit, do some HMAX or like do some hashing, do some computation, and then return that result. And that's the thing you can subscribe to. So that's kind of draws in folks that were frustrated with Firebase, because Firebase gives you all this stuff live, but you have to do all the joins on the client. You have to do all the composition, all the munging on the client. And this lets you keep that, backend logic secret and secure, but still build up that thing. And that's the reason I think in particular we bring up Firebase. And Supabase has some of this, but it's sort of a less cohesive path where you have kind of normal SQL stuff and then you have real time, and you kind of need to think about them separately. And Convex merges them.
So I did some mobile app development. I had a little stint at a company for 6 to 8 months, and we used Firebase. And this idea is like, to me, this idea is really powerful. The Firebase implementation, I'll say, came with a ton of drawbacks that ended up being like contributing to us to actually moving way slower than I would have liked. And we actually ended up moving a lot of our data to Postgres so that we could more quickly iterate. Because as I'm sure you know, like one of the weirdest things about Firebase is like sometimes you have to duplicate your data if you want to get access to it in like fast in like efficient ways. And Firebase actually enforces that you get to it in efficient ways. It like won't let you do it in a slow way, which is nice. But then like you end up with 4 copies of the data, and then you're just trying to build an MVP, and like, it's so anyways, we had ran into some of those problems. But this idea of like, man, it would be so nice. Like I've got this handler, this HTTP handler, and it would be so nice if I could just write a SQL statement that's just a select, right? Like you said, a read. And all of the infrastructure is in place to have my front end app just live update whenever that data that affects that query changes. And like I said, Firebase does this. It sounds like Convex does this. And it's really powerful because a lot of mobile apps, you do want to be very live, right? Like it's especially prevalent, I would say, in mobile apps. In Boot Dev, we are extremely live. It's a kind of real-time game, right? So you're getting your events are happening and you're subscribing to them. It would be awesome for Boot Dev. We had to build all our own infrastructure.
How do you build that? So I've built some of that stuff a few times, and I think there's it's still a thing that could make sense in some cases, right? I can't say like you should always swap in Convex for this, but you always, when I've done it. So I did this at Observable, and another place there's a contract. Another place as a contractor, and you end up recreating the data flow. Sort of, you have your main path of data. Well, at least the way that I did it, you have these queries that give you the data, and that's what you use on that first load. And then on the later loads, you have some kind of pub subsystem that is notifying the right clients. But that who the right clients are is sort of separate logic. And so you are recreating that. And there's a potential for bugs with the discrepancies between these two systems. And are you using like some like Postgres listen notify stuff or a WebSocket server or?
No, so you described it really well. I'll go into a few more implementation details. I think listeners might be interested. So we've got our Postgres database. It's a kind of monolithic, Cloud SQL database running in Google Cloud, and then we've got Kubernetes, and we use Google Cloud PubSub. So basically, whenever something that is live happens, we like make an update to the database, and we write to PubSub and say, "Hey, this thing just got updated," and then we have every logged in client on boot dev has a WebSocket connection to our backend server. Cool. And that server is subscribing to all these events. And it goes, oh, this data just updated that client will be interested in, and pushes it down via WebSocket. So cool. It's not like an insane amount of code, but like it's a lot more than zero. And like it's our code. So we have to like test it, make sure it's working and stuff. It's not like we can offload it to a third party. So I definitely understand like why having that built into the database can be particularly powerful. My follow-up question is, okay, so Firebase is this like NoSQL thing with a lot of like Firebase specific stuff.
Yeah, and the NoSQL aspect you mentioned, right, of like, what's it called? Denormalization. It sucks. Duplicating data, right? Like that, which is how, quote, web scale is achieved on a lot of these NoSQL platforms. Yeah, which is cool, right? Like it is like you got to go wild with some of these things, and you can do it, right? But sorry, go ahead.
When you have small data, it's really annoying, right?
Totally.
Because it's like now I have to write all this code to deal with denormalized data. When at scale, it makes a lot more sense because you're trying to eke out every bit of performance you can. Okay, so Firebase is this like NoSQL, very specific like database. It's not like accessing Firebase is accessing Firebase. It's its own thing. Supabase is built on top of Postgres. What's the deal with Convex? Is it a relational database? Is it SQL based? How does it work?
Yeah. So it's not SQL based, but the NoSQL thing's a little scary because that generally means that, the web scale thing where you need to denormalize your data. So we'd say Convex is still relational. So you still have tables and you still say, oh, in my messages table, no, I'm not going to put all the information there. I'll use a user ID and link out to that. And we give you transactions. So that's kind of the piece you need to safely do something like a join. That's the piece you need to say, hey, I need to take these 100 last messages, and then for each of them retrieve the relevant user, and that better be at the same timestamp, and it better I want each of those messages better have a user, and if it doesn't, that would be I've broken my data model. And in some systems, you just have to account for that because you can only do it for the client, say. And so in Convex, you end up writing these queries in the backend that do these joins, and you can safely do that. So you do use relations, you do split things across a bunch of tables.
Okay, very cool. Yeah, that, like I said, that's my primary concern whenever working with Firebase. And not to say there's never a use case for Firebase,
sure,
but at least after, and it could be my approach to building like quick MVPs and things like that. But after using it for my stuff, I was like, I don't know if this is for me for like quick and dirty things. It was just
totally, and a lot of that, right? Like, and I think some of it does. Well, we hear from people that kind of fall off of Firebase, like they start all in on Firebase and it works well for them, and then they stop using this feature because it doesn't scale, or stop using this feature, and that just the difference over as you scale your app is that's something we're trying to tackle with Convex. It's like, look, you can use it like this with things like you don't have to use a schema initially because some people are into that, like early Mongo style, like, no, just stick data in the database. But then once you use a schema, you get these additional protections. Or, hey, at a certain point, if you needed to denormalize, you can do that. But we're going to start normalize, start beautiful. Right. When you get to the scale, we are trying to eke out performance. Now you can do it, and trying to put all that in one product.
Okay, so tell me a little bit about why you guys chose Rust, if you're familiar with the thinking that went behind that decision over, let's say, well, let's go over a few other possible languages. So, and correct me if I'm wrong on any of these. I believe, is Postgres written in C? C++?
I don't know. That's what I would assume, but I'm not sure.
Let's look it up really quick. Postgres implementation language. Looks like it's written in C. Granted, it's really hard to trust.
That's our alternative C++,
Google
right? It's been around a bit.
Yeah, I think it's written in C. Someone in the comments can definitely fact check me on that. I believe SQLite is also written in C. Mm-hmm. CockroachDB written in Go. Elasticsearch I know is written in Java. I don't know. Is Tiger Beetle? Is that a database?
Yeah, they're all in on Zig.
Zig, right? Okay. Tiger Beetle's the Zig one. Okay, so why did you guys choose Rust?
Sure. Yeah. So some of this, right, is not fundamental stuff about the language. It's about, it was these people coming from Dropbox where they were on teams where they used Rust. And so that's the like, if you're looking for a systems level language, that's the one you'd go to, because they were, I think it was the new sync engine. Sujay, one of the founders, was on that along with some of the other people on the team. That was, sync engine being the thing that is doing the logic of deciding, okay, this, that's the client part of it. Well, there was the client and server parts of it, but the thing is deciding, okay, that change to this file, that's the semantic meaning of it. One of the users on one of your computers using Dropbox dragged this file from here to here. What do we do with that? How do we turn that in? Or how do we sync millions of files potentially? And another system was Magic Pocket, which was doing just backend storage of the backend storage system that was used by Dropbox. And of course, Dropbox was at big scale. So, there, I think it's more reasonable to talk about, gosh, why did you use Rust? Okay, well, it's still very people oriented. There's still culture questions and answers there. But you can say like, because we figured we'd save $20 million instead of $10 million. And that way we could have a larger team of engineers, right? So like, it's very different questions at that scale. And there's reasons we really like Rust. And Sujay would be a great person to have on to like, this kind of his decision along with the others, but they'd all been on teams where they used Rust.
A lot of it sometimes just comes down to like, we're more familiar with Rust than
Zig. Yeah, that's really right? what it was. Like, and some of that is like, I'm familiar with it because I enjoy it and I do it my own time. But most of it was because it was a technical decision at Dropbox I advocated for. And because of that, I've spent with this team years building on Rust. And so I'm confident that we can build these kinds of systems in Rust. And also we've encountered issues where, gosh, we have experienced these other languages, and this really did save us time. There was some of that kind of thing where, gosh, this type system stuff, when you're trying to be really careful, really can help.
When I think of like, man, we really need performance, I always think of Zig, Rust, and C. The thing that surprised me over the last, 15 years or so is how many databases have been implemented in Java. And it's been a big letdown to me.
Yeah.
Primarily because, so as we all know, like JavaScript is, or not JavaScript, Java is garbage collected, kind of like Go is. But man, okay, so I worked a lot with Elasticsearch, which is implemented in Java. And in Elasticsearch, you just get these like very consistent sawtooth memory patterns.
Sure.
That in another language you just wouldn't get. And they're like always the problem.
Yeah.
It's always this like stop the world garbage collection, right? It's like, wait, why did all our queries slow down for a second? It's like, the GC was running. And so I've been really surprised at how many companies have decided to roll with Java. Go does have the same, well, I shouldn't say the same, but Go also has a GC problem. But Go's memory usage is generally more lightweight. Granted, I'm sure that a lot of these companies didn't choose Go because it wasn't around when they started. But yeah, I guess I'm just rambling about how like surprised I am that database companies didn't choose a language that gave them more control. I guess because like you're just working at the like bottom level of the stack. I like there's nowhere down to go from here. And
of course, like the promise, or one of the promises of Rust, right, is like cheap abstractions, right? You get because Java, now I'm just going to tell you about history that I wasn't around for, and that's just stories I've been told. But like, Java, this promising thing of like, here's these abstractions you get to help you organize your code, right? This is really something better than C++ for doing, now we have code that scales. And mostly what I observe of that is like the mess of inheritance and object-oriented code, all this junk, right? But the promise there was that it would help us like actually scale code bases across many people. And I can understand, being willing to pay for some of those abstractions. It's nice to not pay for them. If it's a slower development speed, fine. If it is a slower code speed, I'm less willing to pay for it. But I that's what I would guess. It's people making that trade-off, and maybe it's the run anyway. Yeah, who knows? I'm just imagining. But Rust is pretty fun because it gives you those abstractions without the cost. The cost you pay is you have to wait for the compiler.
I was going to say, like, in Java, correct me if I'm wrong, because I've done some Java, but I'm not an expert. You pay a cost for all of those nested abstractions kind of both at runtime and compile time. And
I don't have that visceral understanding you probably do. I've not worked on a big Java project where like, a significant part of my life was how slow it took for that to run. And I have for Rust. So but I can imagine. Yeah.
Yeah. And if I'm slandering Java, by the way, someone in the comments, let me know, because I'm not 100% sure, but my assumption is with how often like Rust devs talk about zero cost abstractions, the kind of assertion is that many other languages, and I'm kind of just guessing that Java is one of them, is you do take some sort of runtime penalty for a lot of the abstractions that you use. And when we say abstractions, we're talking about like classes and interfaces and inheritance and all this kind of stuff.
And garbage collection, say. Yeah.
And garbage collection, so you don't have to worry about memory, like all that kind of stuff. And like garbage collection is the one that I'm sure, of course, like there is a runtime performance hit for that. But in Rust, the zero cost abstractions one is funny to me because it's like, yeah, you might not pay it like at runtime, but man, do you pay it at compile time. Has that been like an issue, by the way, like for developer speed and productivity at Convex? Is just like, man, we're waiting for these compile times for a while.
Totally. Yeah, absolutely. That is one of the things. And then when you make decisions about how to set up builds or how, for folks that are more familiar with Cargo and saying like, oh shoot, we can only cache these artifacts with one version of the feature flags. If you have a large Rust code base and you have a bunch of packages and you have different ways that you compile those packages called features, there are some places where you only get one copy of those. And so we do things like, okay, go through the code base and all the dependencies, always compile them with the same set of features so that we don't have to blow away these artifacts. And this is just like a little implementation detail. This could change, but it is an example of the kind of thing that, like, yes, we are looking into those things. Sometimes we think about the Stripe Rust package at current date. I imagine this will get improved at some point, but at current date, like when I look down in NeoVim and it says, all right, the reason you're waiting right now is that we are compiling one of your dependencies. And the one we happen to be on right now is often the Stripe package. I'm just like, oh shoot, I wish that was a little faster. So yeah, it's definitely a thing you feel.
Yeah.
And it changes the way
library in Go is massive. Like it's huge. Yeah. Luckily Go compiles quickly, but like it's big.
Yeah. And that does you certainly like look for that a bit, right? And miss that totally. Yeah. And then like some of the Zig stuff, right, was, hey, let's Go and Zig. Like, let's compile fast. That's a neat idea, right? That really is a worthwhile thing. Yeah.
Yeah, Zig has a lot fewer checks, is my understanding. Like it's in terms of like how safe your code is at runtime, it's like somewhere in between C and Rust.
Totally. And I think it's totally the right attitude to be trying to trade off these things, right? Like they're both real things. Anyone that can just say, well, I don't care about the compile time, or I don't care about that safety. It's all in it depends. And the things it depends on are, well, how big is your team? Who's comfortable with it? I could totally see getting really into, I'd probably have trouble with it, but I can imagine the joy of like getting deep into a big Zig code base, especially if I was writing it myself. And I just understand, I rock everything. That would be great. So yeah, it depends. But I think for something like this, where this really is a building block we'd like to be maintaining, for decades potentially, it makes sense to write it in something like Rust, where we really have this control and the abstractions are very, they're maintained by the compiler, and they help us build these building blocks that we know we'll need to refactor, because everybody on the team is like, we're used to needing to build systems that scale. And the system we're building now, it will scale, but it does not scale to infinity right now, right? So when it was built, we draw out the architecture diagram. You say, okay, this is the thing we'll split into a service. This is the thing we'll split into a service someday. This is going to work totally differently, and that affects how we build it now. But the very first version was just a single Rust process doing everything, because that was the easy way to do it. And then you say, okay, great, we have customers, we have scale. It's time to split this thing out into this piece over here that can scale independently for this kind of workload. And then there's some services, like when we built full text search or the vector search, which Convex provides, those is like, well, okay, those are clearly different workloads. We'll go ahead and build those as separate processes. But for a lot of other things, it was very much like draw a circle around this, write an interface, and then know that someday this will be RPC. And like, okay, great, build the whole system knowing that. And that means like, you lose. Sorry, I want to hear what I was going to say. Yeah, it's an interesting way to like plan it, and it's something I would have trouble doing, having built fewer of these systems. But this was folks that really had built these, and they know, okay, I can just see a service here, service here, service here.
That's such a good approach. And the reason I want to call attention to it is because it's also not necessarily obvious. I've seen a lot of people not take this approach. And that is like, okay, you're a new backend developer. You understand the idea that like you want to build scalable systems. And there's a couple different approaches you can take. And you'll hear people arguing about this on Twitter all the time. It's like, okay, you're a small startup, you have no users, just like build something super quick and dirty that you plan to throw away later so that you can test to see if your idea is valid. That's like approach number one that you'll hear on Twitter a lot. Mm-hmm. Approach number two is like, well, we're planning on success and we've done a bunch of research into our users. We're pretty confident about the product. So we're going to build this architecture that's like highly scalable. It'll take longer to deploy, longer to ship, but it's going to scale. And yeah, I would argue the approach that you're describing is 90% of the time the correct one, which is we're going to build something fast. It's not going to have this scalable architecture up front, but we're doing it with like the idea of where the scale is going to happen. And we're going to like think about it that way up front. So an example of this is I've done this in the past where I'm like, okay, I have some data in a Postgres database and a bunch of it's like transactional kind of business logic, like users and users organized into groups and they have all their user preferences and all that crap. It's like, okay, I'm going to put that in these tables over here. And I'm just going to like treat them like I normally would in a SQL database. But I have this other set of data. Let's say it's like, I don't know, comments and posts and likes. So it's like this, like potentially like what would blow up if you had a lot of scale. And I'm still going to put them in Postgres because we're quick, we're early. I don't want to just deploy like this big, NoSQL cluster to handle scale right now. Mm-hmm. But like you said, I'm going to draw some lines and I'm not just going to like join across all of that data and depend and like create all of these interdependencies because my plan is at some point I'll like move that to an external service. And so like thinking a little bit about it up front, it's like, it only takes, a day to think about it, right? Mm-hmm. Like, should I have these problems? What am I going to do? And so you don't have to actually go implement all this stuff, but now you can start to build out that like quick and dirty thing with in such a way that you don't have to rewrite the whole thing from scratch. It's like you have some responsible boundaries in place.
Totally.
I like that a lot. Okay, very cool. So you touched on this idea of backend for front end, and I want to get back to that. We've talked about it a couple times on the pod, and when I heard you say it, it invoked a slightly different idea than what I'm normally used to hearing. So could you explain to me just what you mean by like backend for front end?
Sure. Yeah. So say you're at a larger, so first off, say you're a larger company and your front end, like what I was working on the homepage at Dropbox, your front end, there's a lot of data on there and it might be coming from some different systems. And one extreme approach is you could say, you know what, I'm just going to deploy an SPA at a what's that mean? Single page application. Yeah. I'm just going to deploy some static HTML and JavaScript. And what that JavaScript does is do some auth stuff. And then we're going to use the authentication information I have there to hit 16 different services and compile that data on the front end and get that data directly so that I can build the UI that I need, and then I'll do some polling on the front end too. Like I can put all that stuff in the front end. Often this is not it's a cheap and dirty way to do it. And Firebase is somewhat close to this, but usually this is not an option. You can't do that because the auth is not set up, right? You want to have one place that so just for simplifying the authentication stuff, you would like to have the front end. Right, you want a backend that the front end can say, "Hey, give me this data," and the backend says, "Sure," and then it hits 16 different services.
Yeah, you want some kind of like API gateway or something.
Yeah, right, totally. So that's one aspect of it, and then is the kind of thinking about latency and like, all right, where are I'm doing that already, and I've got maybe it's 10 REST-ish, or not REST, right? Because they're just endpoints, right? And some of them are going to be posts and gets, and they're not going to be exactly REST, but they're just endpoints that I'm hitting somewhere. And then the question is, how much latency is between that thing and those backend services? And how can I do this in a way that it's efficient? And that's the aspect I was more thinking of, where it's just like, where do I place the data? Sometimes this means geographically. where do I place these servers such that I can quickly return that response to the front end? And maybe it's about recurring not too much data, or just like, great, this thing should hit everything and quickly get something. And then the extensions of that are like GraphQL or something, where I really build it up into a single request, and then someone has to write the resolvers to like figure out how to respond to that.
A couple of the companies I've worked at, like in one company, we used GraphQL as this like API gateway. So we had mostly RESTful. Carson Gross is like super angry at me right now for saying that. But
I try to just say endpoints, but that's just not descriptive enough. Yeah.
JSON APIs. The problem is that also
there we go.
GraphQL.
But totally. It does. Yeah.
JSON
It's a good one. Yeah.
But like we have all these Go services that are just like very standard HTTP servers, and then we had like the one GraphQL server sitting in front that like handled the auth and then like just kind of passed all the work along to the backend services. And then at Boot Dev we also have this architecture, but it's not GraphQL. It's just like a REST server and then a bunch of other REST servers. I shouldn't say a bunch. We have like 3.
There's that programmer thing of like there's one thing and then there's n things, and like, oh yeah, totally. I can understand. It's n. Got it.
Once you have 2, it's n. There's no difference between 2 and 100. They're the same. But then there's this other idea, which we also have at Boot Dev, which is what I usually think of when I say backend for front end, which is like a backend rendering server. So like we have our Nux app. Right. And that thing sits in like Cloudflare pages. And it doesn't do anything smart in the sense that like it has no access to data itself. We pretend it's a front end, basically. It could be running anywhere in the world. We have like our backend running in Google Cloud Platform, that's like in a single region. And that's what houses data. And our backend for front end is really just like, we're going to render that HTML so that the client gets, can get scraped by Google, for example, for SEO purposes. Totally.
Yeah. That sounds
like. So you
were
talking about the first one, like the
but that sounds more like what how I heard. The second is more how I hear the term used, I guess. Right. Often it is more. Sorry. Yeah. I think that's a more. That's the way I generally hear the term used. I'm misusing it a bit.
Like when you just hear the word backend for front end, it's just like slightly different layers. Like the API gateway is like the backend for the front end to consume, whereas the rendering server is like the backend to render the front end.
Totally. Yeah. And both of those I think apply to Convex potentially, but the one that applies now, because both of those you would like to be close to your data, right? Like if you could write the code you could write for either from the Cloudflare thing or from the API gateway, if that were close to data, you could do more round trips and it would be all right.
Yes.
Right. And as it is, it's like you really shouldn't, try to get everything at once and try to do everything in parallel from there. And sometimes that means, well, okay, of course we have to write route loaders that describe all the data we want. And then I need to somewhere else, probably not there, combine that data, munge it correctly so I have it all in the right place. And both of those are things that Convex can help with, and that if that backend, either serving the HTML, which is not a thing we recommend right now, or the API gateway, if that stuff's right in the data, in is kind of made up, but next to the database, right, like touching it, then you can write. I want to say nicer code, but you have more options because those like an n+1 query is not actually that big a deal because it's right there.
This is something that I think gets overlooked a lot. So. And it was something that I overlooked, especially like before my first job as a backend developer, when I was kind of doing more full stack stuff. I was very taken in by like, okay, we've got our server running, let's say in AWS. And I read some marketing for a database company that's like, our database is fast. It's really fast, right? And all you have to do is like click a button, you get a database, and we'll give you a connection string. Mm-hmm. And if you're not careful, right, and you're not thinking about latency and location, it's like, man, that database is super fast. I'm going to spin it up. God knows where. You're not even thinking about region, right? And you connect to it with your connection string. Everything seems to be working. Only to realize later that you've got like 50, 100 seconds, 100 milliseconds of latency between your backends and your database. And now if you have to do 3 queries one after the other, like all of the performance is killed by that super fast database. Doesn't matter how fast it is anymore because you completely destroyed all the performance gains you're getting from latency. So like one thing I recommend overtly, this is something I just recently did on Boot Dev, is like hop onto your server. And like, even if you think your database is close to your server, like hop onto your server, like SSH onto it.
Yeah.
And like ping your database and just like a bunch of times, right? Just like see what the latency is. Because, for example, our database, they're both running in Google Cloud in the same region. We get sub-millisecond ping times. So it's like when something's slow, we just know that like if there's 5 database calls one after the other, it's probably not that.
Yeah,
like
totally.
That's like 5 total seconds of latency, or sorry, 5 total milliseconds of latency. So it sounds like Convex is all about shoving these things right next to each other.
Yeah, exactly. Right. And it's similar performance to that, right? Like, okay, it should be sub-millisecond. And that means you still don't want to do 1,000 of these, but you can absolutely do a dozen, right? That's fine.
Yeah. In a lot of cases, it makes your application logic a lot simpler, where you were going to do this like really nasty SQL query that's like hard for anyone to read because it's 100 lines long. But it's like, okay, now we can make it at 3 SQL queries. It's easier to understand the purpose of each. They have their own names, right? We do one after the other. I'm always very hesitant to put space there. It's like, it's okay if you're taking it into account, you're writing these big, huge SQL queries, you're only ever doing one. But in my experience, it's hard. And like, if you can avoid doing that.
And that's part of the Convex thing is like, oh, business logic in SQL just is hard. We're going to let you write it in JavaScript or TypeScript, right?
TypeScript.
So let's pretend that it's not.
Go.
Yeah, right. I know. So, and the architecture is such that you can do it. And then we have like some proof of concepts where you can write it in Rust, but through WebAssembly stuff. But the fundamental architecture, you can write it in anything. Turns out if you're trying to sell this, especially to web developers, it's nice to say, hey, you don't have to learn SQL. You just have to learn Go. Oh, no. You just have to learn TypeScript, the thing you already know. That is an easier pitch, kind of. But yeah, absolutely. And it is combining those such that you can still do it as one big SQL or one big query if you want, but you have a whole programming language. I mean, let's say they're both programming languages. You have a different, easier programming language in which you have abstractions like functions that you already know the syntax for to break that stuff out. And that is a much easier way. Because maybe it is hard to put that wherever it is you're querying from, and you wanted to do those. Maybe it is nice to have all that stuff in one query for some reason. And if you're able to write that query in TypeScript, it is much easier to do that than with SQL.
Very cool. Okay, so I have a question, and maybe like you can just there might be some disclosures. Like, I know you're not the founder or the CEO, but like maybe you could guess. I don't know. My assumption is that the kind of business strategy is like, okay, first we're going to make a dent in the TypeScript market, right? We're going to get a lot of people that are using TypeScript using Convex. And then from there, maybe we'll expand. Do you know if there's plans, should that happen, to expand to support other programming languages? TypeScript and JavaScript make sense, especially in the like React Native, and like we're going direct to the front end world.
Yeah.
I'm curious if there's a plan for Convex to be more of like a database for a backend, if that makes sense. Like we're going to query this thing from our Go service and then proxy the live updates to the client. Yeah,
the pieces we have now are like an unofficial Go client that one of our employees just packed together and that we use internally. Cool. There's a Rust client. But those are clients, right? So you still would have to write the queries in TypeScript. So yeah, absolutely. It's just simpler to not go multi-language yet. So I mean, the client meaning like you can use HTTP to talk to this thing. But if you're doing subscriptions, it's a little more complicated. There's probably a WebSocket involved. And that's where like you might have a long running Go server that has a WebSocket connection to Convex, and it receives, instead of the browser receiving the update, the stuff has changed, it receives the update. Hey, this stuff changed. You kind of have a cache that's automatically updating very close to you. So say if you want that data to be right there. So yeah, that's absolutely the vision, to have many language. You can write queries in many languages. And in fact, right now, you have to spin up a V8 isolate, which is, a lot cheaper than a container, but is not, or at least a V8 context. And we could do better with future technology, probably WebAssembly related, or could be binaries, but there are future, we can make performance even better if it's in another language, probably. But we do not implement that now.
Okay, I've got a follow-up question now, because I realize I misunderstood something. You said the queries are in TypeScript. And for some reason, my head went to what that means is usually you're writing TypeScript, but like the queries are probably like structured JSON. It sounds like that's not the case.
That's not the case. The queries are actually TypeScript, and we are actually running those queries, which is really wacky, right? And
so I give you a string of TypeScript, and you parse it, and like that's the API layer between.
Totally. And it's arbitrary JavaScript, right? You can import NPM libraries in there. Like you can which might make you think, wait, how are you statically analyzing this TypeScript and turning it into something you can turn in a database query? And the answer is we are not statically analyzing it. Right. All the analysis is at runtime. So you just send us a bunch of code, we run it, and then we observe its behavior, and we execute that code in a deterministic runtime so that we know, okay, we just by looking at this, I couldn't tell you what tables it was going to access. But when I ran it with these arguments, it accessed these 6 tables in these ranges of those tables. It accessed this index. And then I can still track the read set. I can say, okay, I know when to invalidate that query result, because the last time I ran this with these arguments, it was, it accessed these things. Now I have a mutation. I have someone changing the data in one of those spots. Say, oh, time to rerun that. And that's when we send back that new result for subscriptions.
So as you said, like the types probably don't matter too much at runtime. I'm guessing it's mostly for developer experience. Like in your editor, you can get completions of all the APIs and stuff like that. Does the LSP that you're using, I'm assuming it's LSP?
So it's all just TypeScript. So we don't have our own LSP. Okay. It is
not LSP. I'm thinking like the types that you export.
Oh, sure.
Right. Like do those dynamically update based on your data, like your schema as well? Because like I can imagine that if I'm interacting with Convex, there's probably a bunch of types for like what functions are available to me,
totally.
what their return types are. Does it update with my schema?
Yeah. So you have, like, when you're writing code, you have there's a little folder, your Convex folder inside of your app. Often it's a web app today, but you can also do this without a web app attached. And in there, you write a schema. The language is it looks kind of, I forget the names of them, but there's other popular like JavaScript or TypeScript, ORM-ish things where you say, hey, right. So I say, hey, I have a table with this name with these fields, and I have another table with this name with these fields, and our types are roughly JSON with some limitations so that we can be multilingual in the future. So like you don't get, JSON does this too, but you don't get undefined and null, because there's no other language I know of where we can say, oh, this value is undefined, but this one is null, and it's the same everywhere else, right? So we have a subset of JavaScript values we can do that with. What was the question?
No, I was just asking about like the types, if they, if your schema essentially updated your kind of the autocompletion stuff that you're going to get in your editor.
Yeah. Although we have this strict separation between, the schema does. So if you write a query which just returns the first 10 rows of one table, and then you are back in your client where you use that query. So first of all, you do have like autocompletion on what queries are available, but you're calling them by name there. You're not writing them in line. You have this other spot where you write all the queries. It's very much like named stored procedures kind of thing, or named queries. Okay. And unlike SQL, where like every time unless you're using prepared statements or something, but like in SQL, right, every time I run a SQL query, I am sending that string over the wire, and the database looks at it and says, oh, sure, I know how to do that. We do it ahead of time. So we say like, no, you just send a name. At deploy time, you give us a list of all the queries, mutations you want. And then when you actually call it, you just say, oh, call this one, please, with these arguments. And then we say, great, we'll do that and return it. And as you're developing, yes, the types kind of flow from the schema through the queries all the way to your client. So you can see those changes happen.
Okay, I want to say that back to you, partly for myself and partly so everyone who's
you'll say it more clearly than I just spewed a bunch of stuff. No. Yeah.
So in SQL, I write a query, and maybe it has some like dynamic interpolation in it. But like when my server is running on my backends and someone hits my endpoint, I'm taking that literal text, select star from blank where blank, right? And I'm sending that text over the wire. The database is going to parse the text. It's going to do its whole thing. What I'm hearing is instead with Convex, you essentially take that query, which is not written in SQL, it's written in TypeScript. And when you deploy a new version of your app, you send it to the database. And you say, this query is called, update user. And then at runtime, all you have to say is update user. Maybe I'm assuming you provide some data with it in the case of
which user. And sure, how to update it.
Yeah. But like, I'm just calling that function. You already know the behavior of the function.
Yeah, exactly. And that's necessary for a few reasons. Like it means, you shouldn't expose, obviously, your SQL database directly to the browser, because someone in the browser can just type out a SQL command.
Yeah.
Like give me all your data. Safer. And it says, here you go, here it is. So you need that layer in between. but that's potentially a latency layer. So it is nice to be able to say, look, here are the things this will respond to. And some databases try to do this, like Firebase does this with, we'll just put permissions on everything, and we'll build the auth in so that, yes, you can run arbitrary queries from the client, but they are constrained by this. And that kind of works, but it is, again, a separate step. And so in ours, you just write these endpoints, you check auth in each of those endpoints. If not everyone on the internet should be allowed to hit this endpoint, then you say, oh, this should be an auth endpoint. But that's something that you're doing in there. And then another purpose of this is, sometimes you're importing, if you're probably aware of NPM package, node modules, sometimes they're big, right? Sometimes this query
Not
could
sometimes.
be 3 megabytes, right? Yeah. So it is possible if you don't import anything, your Convex query could be kind of small, but you can import a lot of libraries and you get a fair bit of compute time in that query. So we wouldn't want you sending over the wire, even if it was from a server instead of the browser, we wouldn't want you sending 3 megabytes of JavaScript over the wire. So we want to have that JavaScript queued up and ready to go, already in cache, so we can run it especially quickly.
That's interesting. I really like that idea. So listeners of the pod will have heard this a couple times. A few months ago, oh man, maybe it's even been almost a year now, we switched I don't know what I'd even call it, like the database interface. That's still not quite as precise as I'd like it to be, but we use sqlc to talk to our database now in Go rather than Gorm, which is what we were using before. And the big difference is that in Gorm, if you wanted to do raw SQL, you wrote it as a string. And it did like the nice escaping and security things. But when you're writing SQL as a string in Go, first of all, you're not getting syntax highlighting, right? You're not getting auto formatting, but most importantly, you're not getting any sort of type safety, right? If you just mistype the name of the table, there's no way for you to know that till you actually run the SQL query. The great thing about sqlc, the reason I'm so excited about it and have been happy to use it, is you write your SQL as SQL and then you compile it. And at that compile step, it can yell at you and tell you, hey, you mistyped the name of the table. Hey, the type of this field is different. You're trying to use it here. And so it creates a connection between your application code and your database that is type safe. So like this idea of using TypeScript instead of JavaScript seems really obvious to me, like in hindsight. And I love it because every NoSQL database that I've used so far has been JSON interface. And that is not type safe in any way. I mean, like in theory, you could build some tooling on top of it, but TypeScript's type system is much more expressive than just like the few different types you get in JSON.
Totally. Yeah, and it's been a great kind of, I want to say shortcut, because like obviously we have to support other languages, but it is convenient that we lean so hard on TypeScript because we have all the information, right? We know what your schema is, both at runtime, we know what data is in there, and we do some shape tracking so we can tell you if you don't have a schema, the observed schema looks like this, or probably you specify a schema. We have that. We have the types. So in the queries, you have good type safety while you're writing that TypeScript, and then all the way to the client. If the client consuming it is also TypeScript, those types just flow through. But we need to do a lot of code gen for things like Go because we also want types there, and the TypeScript language server does not, work when you're editing Go code. So those are pieces that need to be tackled, and those are generally understood things. Of like, of course you do, you write a code generator that generates the Go code to say this is what I expect, like it's protobuf or something.
Yeah, I mean, now that I understand what you're saying a little better, it doesn't sound like nearly as much of a problem that you're just in TypeScript because, for example, should you ship a Go implementation, it could look just like SQLC in the sense that like you write all your TypeScript queries in TypeScript, you get your beautiful LSP, blah, 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 and it code gens Go. Or you could do it the reverse way.
It does mean the Go developers have to learn TypeScript though. And that's a piece we'd like to fix, right? Like, and it means you're paying the overhead of executing TypeScript, which is not a compiled language. We have to run V8 to do it. So we absolutely want to have Go. I mean, Rust might be first because it's our thing there, but like you should absolutely be able to write your queries in Go someday. And it would be the I don't know, is it CGo? Whatever type of Go compiles a WebAssembly first, maybe.
C-Go.
But
don't do CGo.
Don't do CGo? Okay. Good. I'm pretty into the Go stuff. That's helpful.
As a Go developer, I think, granted I haven't used Convex yet, like my preferred way would be to do it the sqlc way, which would be like, I just write the TypeScript queries and then run some code gen to generate the Go that maps to the TypeScript. And I know like
Cool.
you'll say, but then like the Go developers have to learn TypeScript. My hot take, and it might especially be biased because I'm an educator, but like I don't care. Like learn TypeScript. Like
Sure.
I would rather have my developers just like learn the tool that they're using. It would be great if you could just write the Go and like at deploy time ship the Go to the database and have it do the whole thing. Like that would be great too. But to me, it doesn't seem like it would be too painful, especially as like an intermediate step, to be like, well, I'll just write the TypeScript queries and then it'll compile.
Absolutely. And we've certainly been pushing on the clients a lot more than we have on the, that other stuff will happen, but building out more capabilities for the TypeScript query language is kind of more important for now than letting people run other languages.
TypeScript type system's like really expressive, like more expressive than Go's. So there's
that's what, nice when you described me at the beginning as a Rust engineer or the part that holds me back is like, I spend a lot of time writing TypeScript. It's not like, it's just the types, right? Like it'll be a long page and there's 3 lines of very simple TypeScript, JavaScript really at the bottom. And then there's 200 lines of TypeScript at the top because we want to provide that very expressive query language thing. And it's always for the code in there, right? The clients, like we have to write a React client and things, but that's not too bad. We just propagate the types through. But when you're in there, we want to provide, great support for things you can do in a query, like, or especially in a mutation, like, I want to schedule this function to run later with these arguments, or, hey, I want to run, all these queries in parallel and then bring back the result here. And getting good support for that in a way like that auto updates with your schema or auto updates with, if you're scheduling other functions, which functions exist and what arguments they take. That's some of the interesting, tricky bits.
I am so far on camp. Like TypeScript makes application development easier. And I have a really hard time understanding the arguments for like why you wouldn't want that. I can understand arguments for like why you'd allow any in your code base or whatever, right? To like, this is just getting ridiculous. Let's just throw an any in. I don't understand why anyone would want to do JavaScript at the application level.
Yeah.
But the important caveat there is it's because you're offloading like all of the hard work onto like the libraries that you're using, right? If you're using Vue or if you're using Nux or if you're using Convex, like TypeScript's only easy because all of the wonderful types have been handed to you on a silver platter by, whatever APIs you're calling.
Yeah. It's been fun to somewhat join the ranks of. There's a lot of other folks that are doing even more interesting stuff there, but to be like, the way I get support on this stuff is I tweet about it and ask some people who I support on GitHub, partially because I'm like, I really appreciate your open source contributions, and part of those contributions are that I can go look at how this works in this other library because it's some fancy stuff. I've done a little bit of. Like find some blog posts on TypeScript. I've not done a paid course yet, but like that would totally make sense based on how much time I spend talking to ChatGPT about TypeScript or like trying stuff in the TypeScript playgrounds. Like I always have several TypeScript playgrounds open to try out some things because it's the constraints of our API are at least the parts that are TypeScript specific are so determined by what we can figure out how to type, because it's how much can we support you when you're trying to do this thing. And it's incredible what you can do. And then that's lots of time spent on that.
We have plans to ship a TypeScript course at Boot Dev. So just hold out for that one.
Perfect. Yeah, will.
The main problem is figuring out how, because like obviously, if you're going to ship a TypeScript course, you need the TypeScript LSP. Like, duh.
Sure.
It's like the whole point.
Yeah.
Right. So we do need to figure out how to make that work in the browser.
Tom McWright, my old coworker, has done some blogging about this on for Valtown. If you heard of Valtown, it's kind of this like just hit Dino endpoints in the cloud. This is a coworker of mine at Observable. Really impressive guy, but has done a lot of writing recently on, hey, how do we provide a TypeScript experience in the browser that provides this stuff that is not, I believe, not round tripping with a Dino server somewhere. It's all in the browser, I think.
It's like I want some sort of like WebAssembly, like I want the LSP running in WebAssembly in a web worker or something.
Totally,
like, So, anyways, TypeScript is definitely like coming up on our roadmap soon, but we'll definitely be shipping some tooling because there's no way we're shipping a TypeScript course that doesn't have like full LSP support and all that kind of stuff.
Sure.
So
yeah.
Cool. This has been awesome. Thanks so much for coming on. This has been a lot of fun. It's convex.dev is the database that we've been talking about. Is there anything else that you want to plug or share with the listeners?
Sure. Convex is the thing I think about a lot. I've got a blog and a Twitter and things. I do talk about
Plug
other
them.
things
Where
sometimes.
can people find it? Yeah.
Oh yeah. Twitter is Ballingt, Ballingt, ballingt.com. I try to blog there sometimes, but the thing. It just gets longer and longer between posts.
Yeah.
But there's some fun stuff I've done on there in the past that I'd love to talk about. Yeah.
Awesome. Cool. Well, thanks for coming on, man. It's been fun. Go find Thomas at Ballingt on Twitter and convex.dev if you're interested in the database. Talk to you later, man.
Great. Thanks so much.